A rhombus is a quadrilateral with four congruent sides. It is a parallelogram, so it does hold all the properties of parallelograms. The difference between a rhombus and a square is that a rhombus may not have 90-degree angles, where a square always has those 90-degree angles. However, it does share some things in common with squares in the fact that the diagonals are perpendicular. So the diagonals are perpendicular in both rhombi and squares. Rhombi or rhombuses is the plural version of rhombus. And it also does bisect opposite angles like squares do. However, since in rhombuses or rhombi, the angles are not necessarily 90 degrees, that doesn't mean that, or doesn't necessarily mean that all the angles are 45 degrees, like it does in squares. So this angle is congruent to this angle. And since it's a property or holds properties of parallelograms, that also means that this angle is congruent to this angle. All four of those angles are congruent. And then same here, these two angles are congruent. And these two angles are congruent. And since opposite angles are congruent in parallelograms, all four of those angles are congruent. But again, it's not going to necessarily be 45 degrees. Unless your rhombus is a square, then all those angles would be 45 degrees and all of them will be equal. So that is, those are the special properties of rhombuses or rhombi, whatever you prefer to call a rhombus in plural version is okay with me. Now when we name a rhombus, we again cannot draw a little symbol like we did with parallelograms because any symbol that we are going to draw is going to look like a parallelogram. So we actually need to write out the word rhombus. I am okay with you abbreviating to this. And then write down your four letters. In order, again, you can't go across the diagonals. All right, so let's practice. The y got cut off here, but this is a 3/5 y. And we're going to solve for all the unknowns in each of the rhombuses, rhombi, whatever. So in a rhombus, all four sides are congruent. So this 12 side and this 3/5 y side are going to be set equal to one another. Multiplying both sides by 5, I wind up with a 3y is 60. Dividing by 3 on both sides, y comes out to be 20. Again, all four sides are equal or congruent, so I can set these two sides equal to one another and solve for y. Subtracting the 2y over, I wind up with this, and then dividing both sides by 4, I wind up with y is a 7.25. Okay, next problem. All four sides are equal, so to find x, I'm going to set that 2x minus 6 equal to 10. I'm going to add 6 to both sides. I'm going to divide by 2 on both sides. I get x is 8. Again, all four sides are equal, so that 5y can also be set equal to 10. And dividing by 5 on both sides, y comes out to be 2. And for this one, since, and there's a couple of different ways that you can do this, since we have two sides being equal here, this is an isosceles triangle. Opposite angles are congruent, so this is also 72, which makes, and this is also an isosceles triangle because, again, all four sides are congruent. Base angles of isosceles triangles are congruent, so these two angles would be congruent. So if I do 180 minus that 72 degree angle, and then I divide by 2, I wind up with what angle Z is, which is 54 degrees. All right, next problem. I can set that 3x plus 2 equal to 8 because all 4 sides are congruent. Subtracting 2 from both sides, I get 3x is equal to 6, and dividing by 3 on both sides, x comes out to be 2. For y, I have a 1/2 y squared. I can set that equal to 8. Multiplying by 2 on both sides, I get y squared is equal to 16. And taking the square root of both sides, be careful here when we're taking the square root of something, it can be positive or -4, and both of these answers work in terms of this situation. And then same thing here, opposite angles are congruent. So this is 86 degrees. This is an isosceles triangle because these two sides are congruent, which means base angles are congruent. And so if I do 180 minus that 86 and then divide by 2, I wind up with Z is equal to 47 degrees. All right, moving on. We're going to determine if the following conclusions are valid, and if not, we're going to tell which additional information is needed to make it valid. So we were given that ABC is a right angle. So this is a right angle here. And we want to determine if ABCD is a rectangle given this information. Well, if we're only given that this is a right angle here, we cannot determine that this is a rectangle because we could have something that looks like this. And that's not a rectangle, that is a trapezoid. So in order to make this valid, what we could know is that this is a parallelogram, and then that would mean that opposite angles are congruent here, making this 90 degrees, which would need to make these two 90 degrees as well. So that's just one set of information that we could know in order to make the conclusion valid. All right, the next one here, we are given that EF and FG are congruent, and then we're given that EH and FH are perpendicular, and they're saying then that EFGH is a rhombus. We haven't gone too much into detail with kites yet. However, we do not have enough information to say that this is valid because we could have that EH is congruent to HG, and that would make this a kite. Which EF and EH might not be congruent. So we cannot say that these are, or that this is valid. But if we did know, again, that this was a parallelogram, or if we did know that EF and EH were congruent, then we could say that it is valid. However, I'm just going to use the information that it is a parallelogram. I'm going to use the same explanation that I have over here. if you want to say we would need to know that EF and EH are congruent or GF and GH are congruent, that would be okay. But with the information as we have it, as it stands, we do not necessarily know. And these questions were a little bit difficult because we haven't learned about trapezoids. We haven't learned about kites yet. And so that's why I guided you through these two problems. All right, that brings us to the end of the rhombus section.